Okay, welcome. So my network is an official co-sponsor of this event. Welcome, thank you for joining. I'm going to talk a little bit today about FHE, Fully Homomorphic Encryption. I'll tell you a little bit about my network's journey leading this space. And I always like to start out just to check and engage how we're doing in our marketing department. So how many people have learned about FHE or are aware of Fully Homomorphic Encryption? Let's see, raise your hands. I'll take 1, 2, go, okay, all right. What you have to know about FHE is it's the most advanced encryption method. It's the ability to encrypt upon, to compute upon encrypted data without decrypting it. It's existed for 40 years, but it was theoretical for many decades. Its first application was in 2009 by a Stanford PhD named Craig Gentry. And what Craig figured out you could do is you could use FHE in his processing of genomic data. They were trying to sequence the human genome for the first time. And so that was the first time it left academia and research papers and went into application. And so since then we've been looking for new areas where we can apply FHE, because if you don't have to decrypt information, this is the superior method for data processing, data transfer, and data storage. So if we can start to find places in tech stacks where this is applicable, where this is performant now, we're increasing security all over the place. We have friends in this field, namely Zama, who's the #1 cryptographic resource provider for Web2 and Web3 companies globally. They proposed an idea called HTTP-Z. The Z stands for Zero Trust. So imagine environments where all data is treated as non-trustable and must be verified. This would be an end-to-end encrypted web. I'm going to go over why that's important. So if you are familiar with FHE, for the few people that raised their hands, what you've probably heard is that it's still slow and it is computationally intensive. If you encrypt with FHE, you also have to decrypt with FHE in scenarios where you do need decryption. So this is a problem. Right now, we probably, with FHE development, are where ZK was in 2020. So if you've seen the ZK boom recently, this is probably what we can expect from FHE in the next few years. I don't think it will take 4 years because hardware acceleration is on an exponential curve at the moment, as well as schemes are on also an exponential curve. So we're seeing really rapid development. And the key feature, like I said, the key challenge for us is finding areas in tech stacks where FHE is performant now. And if we look to ZK as an example, the first place that ZK was innovative was in validating transactions. And in kind, this is where FHE has been applied as well. Now, FHE is not really competitive with ZK, and I'll explain the difference so that we're all on the same page about it. But ZK is performing the computation by a provider. That provider sees the raw data, and only the proof goes on-chain. The computation does not go on-chain, which means it's not verifiable. The proof is verifiable. With FHE, the computation happens on-chain as well. Okay, so this is a superior solution if we can use it. In some cases, ZK, FHE go hand in hand. So we launched a data lake, was our first product, FHE data lake. We integrated that with Arweave SPF and Arweave IPFS and Greenfield, and we use ZK for input-output, and then FHE for the encryption, as well as the processing. And this was received really well by the market. In the early days, decentralized data storage did not have high use case yet. We were looking for a larger total addressable market. So that SDK is built and it's live and it's ready. We expect a boomerang effect on that, but in the meantime, we kept iterating. So like I mentioned on the panel that I was on earlier, we were talking with CCIP's capital markets team. And in 2023, last summer, 2023, Chainlink was running its beta test for its cross-chain interoperability protocol. This was essentially an institutional pointed bridge that was made to bridge assets from stablecoins into public chains, bank stablecoins into public chains, and back again. There's an incredible amount of efficiency and value that will be generated once we can go from T+2 in settlements in the traditional institutional sector, institutional asset sector, to T+1 and then to T+0. This is an incredible amount of efficiency, unlocking trillions of dollars of value. So banks are really keen on getting this accomplished. The issue that Chainlink was having was that there's a messaging layer that goes out in front of every transaction that initiates the transaction on the network, in this case on the bridge network, which is Chainlink's decentralized oracle network. All those oracles could see the message. They could see the transaction before it was executed. Now, if you're a bad actor running one of those nodes, you can front run that trade. That is a non-starter, and that would make Chainlink persona non grata with any regulator. If that happened, now as much as Chainlink swore up and down, this is the most secure bridge in Web3, that's not enough for regulators. It might be enough in Web3, but not enough for traditional regulators. So we used FHE to encrypt that messaging layer, and it turned out the computation is not very intensive. You can do this pretty easily, and the time that we had to beat in terms of speed was a day or two. This is easy. We can do the most advanced FHE computation imaginable inside of 20 minutes. So we've got 2 days left over. So this is a really key solution, and we can incorporate this solution into, we're working with Wormhole, with Everclear, formerly Connect, to do the same thing. So along this line of trying to find places in tech stacks where FHE is performing, we're finding new applications all the time. These are the first 2 products that we shipped. And so this is very exciting. We're starting to build up a use case for FHE. It's leaving theory, it's gone into application. Now, Vitalik's been talking about private voting for quite some time. It started out with DAOs in 2018 because he recognized that DAOs had entities and voters that had a lot of staked assets. They were more powerful than the other participants in the market, and they were influencing other participants in the market. And so, in the DAO. So, if you can encrypt the votes, this was in DAOs again, DAO use case in 2017, you create a shared private state, nobody can see anybody else's answer, nobody can be bullied, nobody can be coerced, okay, into producing a specific kind of output. If you scale this up and you look at chains, what validators do, whether they're checker validators, chain validators, AI validators, we have the same problem. You want to create a shared private state so there's no influence among the actors. You also don't want lazy nodes. You don't want nodes that are copying the outputs of other nodes, that are looking at how many resources a specific node provider has, like for example in an AI network, they're staking $500,000 of tokens. You might reasonably assume that they've got a lot of compute resources, a lot of capital resources, so let's just copy them to increase our own chances as a validator of receiving the rewards for that function, whatever it is. So this is out of Vitalik's mouth at the Hong Kong Web3 Festival. If you really want private voting to scale, you have to use FHE plus MPC, and this is the exact framework that my network has optimized. And so we built this FHE layer, so we're not a chain, we don't have chain ambitions, we are very friendly with Phoenix, who you might have heard of, as well as Inco. They're an L2 and L1 respectively, they put FHE in the Genesis block, and we expect that they will be very big in the near future. But in the meantime, we're looking for where FHE is performing right now. So this is a framework. I'm going to talk about our 2 newest solutions that we've launched this year. The first one is voting for AI networks. So if you look at AI, first of all, broadly speaking, everyone knows how big this industry is. There's hundreds of billions of dollars of capital going into AI. And there are problems in centralized AI that decentralized AI can solve. We're looking at projects like Aether, helping with compute, things IONET. But a lot of these AI networks use a very standard framework, which is that you've got models, miners that build models, and then you've got validators that rank those models. Now, how they rank those models is up to the subnet. It's up to the network themselves, but they have to run computation to rank or verify the model. As early contributors to BitTensor and other networks, we noticed that there were 2 problems. The first one was that miners, the model makers, were jumping on the other side of the line and actually ranking their own models. So there's obviously a conflict of interest there. We don't want that ability. Secondly, validators were copying each other. So they were looking to which validators got the most resources or the most TAO tokens staked. Let's copy that validator because they're probably going to get the answer right, increasing our own ability to when the tokens are awarded for that block. So by creating a shared private state, just for the outputs, we found that this is an incredible security upgrade for all these AI networks. And we partnered with dozens of AI networks who have all told us this is a problem. And the reason that users don't know it's a problem yet is because there aren't a lot of decentralized AI models being used at the moment. But as we scale, and model reliability and functionality is a key metric for decentralized AI to scale, it could be the key metric, you could really consider it that. This is going to be pivotal. You have to create a shared private state, increase the security of the miner-validator relationship. So this is just kind of a framework of what that looks like. So we have an FHE validation SDK. So basically, those validators that are ranking models are going to send their output to my network. We encrypt it, we send it back, and that's what actually goes on chain. So you can't actually see the data. All the validators have to do their own work. This, if you think about it, also allows you to scale your validator network more quickly. Because if you're trying to scale a validator network, one of the attack vectors you're worried about is the copy problem. This is why when we see new L1s or new L2s over the last several years, they usually have a very small list of validators up front, sometimes 12 or 20. Those validator nodes are usually run by trusted friends, parties, investors. And it's expensive, of course, to do this as well, to scale, taking into account all the security and all the audits that are necessary. So this gives you one less attack vector to worry about. Zama, like I said earlier, is the biggest cryptographic resource provider. They have an FHE EVM library, TFHE library. Most of the FHE projects in Web3 are using them. They are now very keen to go in AI. They pointed all their productization to AI, and what they've created is a concrete ML SDK that allows miners to host and develop models using FHE. What that means is they're creating a way to protect the data inputs into the model. So this does two things. Number one, it protects data segmentation, user profile data, the sensitive data that we're all giving openly to the centralized AI networks, so that they can basically productize that data, keep it on their server, get breached every 6 months, and share it with the dark web. Zama's created a way to protect that. But secondly, if you're a decentralized AI developer, you now have an ability to protect your IP. You can punch up. You can compete against bigger dev houses or even centralized AI models because you now have an ability to keep your parameters and your weights protected. So this is a key ingredient for scaling decentralized AI by empowering single developers that have useful models that work. And just to finish that, so that's what Zama has done, and then of course we bring the FHE validation. So that framework that I proposed, or that I mentioned, is the modus operandi in AI, miners and models and validators. We're using FHE in the validation, they're protecting the models. Then we've got token economic security. So what we noticed is that in the restaking game, the key metric is, say it with me, TVL. They're all playing the TVL game. This is because restaking is not a terribly difficult technology to create. This is not a transformative technology like blockchains were, smart contracts, or even FHE. You have to scale using getting TVL. That shows credibility, it shows trust, it shows security. But then, all of this potential governing power is sitting in a vault, and it's definitely proving that project, Eigenlayer for example, is secure. However, it's just sitting there idle. Yes, it's spitting off rewards, but what we found is really interesting in these AI networks, which is that 7-8 years ago, we had this narrative in crypto of governance. What's the governance of your token? Then everybody figured out, well, there's nothing to govern, there's nothing going on in these chains. And the whole narrative shifted to utility. So for the last several years, when we meet a project or a founder, we say, what is your utility? What does the token actually do? Now, there's been a boomerang effect to governance again. In AI, we have a lot to do. There's a lot to govern. These models, new models are being made all the time that are performing key functions. What we need is validation. So we actually need governance again. And what's sitting in all of these vaults and all this TVL? Tens of billions of dollars of governing power. So we've used FHE to decouple the value of the asset from governance. And we can do that with FHE without having to move the asset out of the vault. So it can stay wherever it is, and we point the governing power to our AI customers. So this has been an incredible innovation that our tech team has come up with, and we pitched to our restaking partners. And we've been able to bring on all the partners you see on the left here, Eigenlayer, Symbiotic, Babylon, Puffer, EtherFi, all now friends. And this kind of TVL we call total governance value, TGV. So we're not actually building up our own TVL. This is not sitting in our vaults. This is still sitting in the vaults of our partners. We're just decoupling the governing power from it and pointing it to our AI customers. So it's a win-win-win situation. Our AI friends that are operating as if all AI networks are kind of like new L1s, they get this essential governing power that they need. Our restaking partners now have extra utility added for their token. Their stakers also get an extra layer of yield, which is mine token. and everybody wins. On the right, these are our customers. So our customers are paying us for FHE validation. So again, they're doing those validators, those checker nodes, whatever they are running the computation on their own. They send to my network, we create a shared private state, we send it back, and that's what they publish on chain. And then just a little bit about us, we're Ethereum fellows. Our research has been in Cornell. We had testnet earlier this year, 650,000 wallets, 3.5 million transactions. We're in private mainnet now, which we launched at ETH Brussels. Public mainnet is going live in a couple of weeks. So we're very excited about this space. And we just closed a $10 million round, which again, just saying that to kind of show again, FHE is scaling. We are finding more solutions. It's going to be a very, very exciting technology, particularly over the next 12 months. So that is the state of play with FHE. If you have any questions, please feel free to ask.